Hello class, and welcome to today's algebra lesson, which is about weighted averages. By the end of today's lesson, you will be able to solve both mixture and uniform motion problems. Mixture problems are problems where you are combining two or more parts at different quantities to make a whole. So you're taking different percentages, different fractions of two things, and mixing them together to get a new whole product. Uniform motion problems are problems that involve speed of an object. When you are solving those problems, your formula that you are going to use is distance is equal to rate times time. So we're going to hold on to that formula for when we get to the uniform motion problems. We're going to start with a couple examples of mixture problems. So to make a trail mix, a company mixes peanuts and raisins into the product. They sell the mix for $5 per pound. If peanuts cost $2.10 per pound and raisins cost $7 per pound. How many pounds of raisins should be added to 5 pounds of peanuts to make the trail mix? So this is a mixture problem. When we are setting this up along this side, I usually label it just A, B, and mix. If you want to be more specific, in this problem you could say peanuts, raisins, and mix. Up top, we want to include the actual labels of the quantities that we are using. So in this case, our first label is money, and our second label is pounds. The last value here is always going to be total. So there's going to be two different labels, and then this third one is always going to be total. Now we want to fill in the actual information that we are given. So it says they sell the mix for $5 per pound. So $5 under the mix category. It says peanuts are $2.10, and then it says raisins cost $7. The question is, how many pounds of raisins? So the how many is going to be your X. So in this case, that's our pounds of raisins. And then is added to 5 pounds of peanuts to get the mix. We are adding those things together. We are combining them to get the trail mix. So my pounds for the mix is going to be whatever we have for the raisins plus the 5 pounds that we have for the peanuts. When you are doing this total column, the way we find that is going to be through multiplication. So I'm going to multiply each of these values. So the total for the first one is going to be 2.10 times 5. The middle column total, the middle row total is 7x. And then the bottom row total is 5 times x plus 5. So we have that multiplication there. Now we're going to set it up into an actual equation, and that's where I'm going to do the multiplication. So 2.1 times 5 is going to give me 10.5 plus, mixing in the 7x, is equal to the mixture, which in this case is going to be 5x plus 25 after I do my distributive property. Now we have an equation with variables on both sides. I'm going to subtract the 5x to keep my coefficients positive. You could subtract 7x from both sides if you prefer to do that. We have 10.5 plus 2x is equal to 25. Then I'm going to go ahead and subtract the 10.5 on both sides. And when I do that, that is going to give me 2x is equal to 14.5. And I finish by dividing by 2 on both sides, which is going to give me x is equal to 7.25. And then I need to make sure I include the label, which in this case is going to be pounds of raisins. You want to specify not only that it's pounds, but pounds of raisins because that is the value that we were looking for. We also could have another type of mixture problem where they give us more of the total information. So we have recipe A is 50% peanut butter. Recipe B has 80% peanut butter. How much of each dough should be used to make 100 ounces of 68% peanut butter? So once again, I'm going to start with A, B, and mix. My labels in this case are going to be the percents, the ounces, and then that final column being the total. It tells us that recipe A has 50% peanut butter, recipe B has 80%, and then it tells us the mixture is 68%. In this case, they tell us that the total mixture is 100 ounces. They don't tell us either of the other two values. So you get to pick if the X goes in the first box or in the second box. I'm going to put it here in the second box. Then to find the other value, you would take your total, which is the 100, and subtract off X, aka subtract off one of the values. When I subtract off 1 from the total, that's going to give me the other value. Once again, to find that last column, I'm going to do that by multiplication. So my first row is 50 times the quantity of 100 minus X. The second row is going to be 80 times X. And the bottom row is going to be 68 times 100. Setting it up into my problem, I'm going to have 5,000, so 50 times 100, minus 50x, plus the 80x, is equal to 6,800. In this case, I have the first S in SADMEP, which is the simplify, because I have two x's on the same side of my equation. So I have negative 50x plus 80x, which is going to give me now 5,000 plus 30x, negative 50 plus 80 is 30, is equal to 6,800. Continuing on, I'm going to do a subtraction step by subtracting 5,000 on both sides of my equation, which is going to give me 30x is equal to 1,800. And then I'm going to finish by dividing by 30 on both sides. That's going to give me that x is equal to 60. Now, the x is under ounces of B. So what that means is I'm going to use 60 ounces of recipe B. We also then have to plug that back in to find recipe A, aka 100 minus 60, which is going to give me 40 ounces of recipe A. So we need to make sure if it's asking for how much of each, that we answer both parts of the question and tell them both answers. Go ahead and try this mixture problem on your own. So we've got A, B, and mix. In this case, our labels are gallons and percent, and then we have the total. We are just looking for one of the values, so I end up with 12.5 gallons of solution B. Again, make sure that you are specifying that it is solution B. Moving on to my uniform motion problems, I have Ann and Bob are biking in opposite directions around a circular trail. The trail is 5 miles long. If Ann is biking at 12 miles per hour, counterclockwise, and Bob is traveling at 18 miles per hour clockwise, how long until they meet each other? So our setup here is slightly different. We still have A and B. We still have our two quantities, but there's no mixture anymore. There's no mix that we have for this problem. We're going to plug in rate and time, and then instead of having that final column be total, that's going to be our distance. Plugging in what we know that Ann is traveling at a rate of 12 miles per hour and Bob is traveling at a rate of 18 miles per hour. We know that they start biking at the same time, so that means whatever time they are traveling is going to be the same. In this case, it's going to be x for both of them. Then to get our distance, it's rate times time. So Ann is traveling for 12x and Bob is traveling for 18x. Now, in this type of problem, they give us a final distance. So we can add our final distance of 5 into the problem. So our equation then becomes Anne's traveling, so 12x, plus Bob's traveling, his distance of 18x, is equal to 5x. We're going to do that S simplify step to combine my like terms. 12 plus 18 gives me 30x is equal to 5. And then I'm going to solve by dividing by 30 on both sides. And that's going to give me x is equal to 0.1 and then 6 repeating. So you can write that out as either 0.16 repeating hours, or you could multiply that by 60 and get an answer of 10 minutes. That's how long it would take them to meet back up. Go ahead and try this one on your own. So we've got Avery's speed, Nick's speed. They leave at the same time, total of 24. As you solve, you either get 1.2 hours or an hour and 12 minutes. Last example here, we have a metro train leaves a station traveling at 40 miles per hour. 45 minutes later, on a parallel track, the suburban train leaves traveling 60 miles per hour. When will the suburban train catch up to the metro train? Once again, we start our problem with those two different things, so train A and train B, or metro and suburban, and then we have rate, time, and distance. We know that the metro train is traveling at 40 miles per hour, and the suburban train is traveling at 60 miles per hour. We also know that the metro train left 45 minutes earlier. Notice 45 is in minutes and the other values are in hours. So I want to turn that 45 minutes into its fraction of an hour, aka 3/4 or 0.75 hours. Now the metro train was the one that left first, so the metro, however long it's been traveling, it has the extra 45 minutes or 0.75 hours. The suburban train has only been traveling for that X value because it didn't have the extra head start time. So then, when I move across, I've got 40 times X plus 0.75 and 60X for my suburban train. We want the suburban one to catch up to the metro one, so that means they need to have traveled the same distance. So my equation then becomes 40x plus 30, after my distribution on the first part, is equal to the distance that the suburban train traveled. Going ahead to solve, I'm going to move my variables, so subtract the 40x on both sides, and that's going to give me 30 is equal to 20x. I'm going to go ahead and finish by dividing by 20 on both sides, and that's going to give me an answer of x is equal to 1.5 hours or 1 hour and 30 minutes if you prefer to convert into hours and minutes. Go ahead and try this one on your own. So we have Chase and his mom. We have their speeds. Chase has the extra half an hour. Setting them equal and dividing, it's going to take her 0.375 hours or 22.5 minutes to catch up. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.